Good morning to all. Today the topic I am going to discuss is chemical kinetics. What is chemical kinetics? Chemical kinetics is nothing but which deals the study of rate of the reaction and mechanism of the chemical reaction. The term chemical kinetics was first introduced by Peter Bage in the year 1864. He was a Norwegian chemist. Then he was formulating rate of the reaction with law of mass action. What is chemical kinetics? Chemical kinetics is otherwise known as reaction kinetics. What is kinetics? Kinetics means dynamics. Dynamics means that is movement. So we can say movement of the chemical reaction. So movement of the chemical reaction. So movement means the reactant to product, meanwhile product to reactant. This is what we are saying as a movement in chemical reaction. So chemical reaction can be considered with speed of a moving body. So rate of the reaction is nothing but speed of a chemical reaction. Speed of the chemical reaction is compared with a moving body. So what is speed? Speed is nothing but distance travelled per unit time. Distance travelled per unit time. So what is the distance travelled? For example, let us consider a bus operates from Erode to Coimbatore. So we can say the distance travelled is 100 kilometer. Then the time taken is around 2 hours. Then what is the unit of distance? Unit of the distance we can say as kilometer. Then what is the unit of time? Time we can say as hours. So unit of speed is equal to kilometer per hour. So speed of the moving body is compared with the rate of the reaction. So speed is equal to distance by time. Thereby we could say what we can say like so speed rate is nothing but which is what is speed of the chemical reaction. So rate of the reaction is equal to change in concentration per time. So rate is equal to change in concentration per time. So change in concentration means the conversion of reactant concentration into product concentration. Then unit of rate of the reaction is equal to same way as we mentioned in the case of speed. Here also we can find out the unit of rate of the reaction. So that is nothing but concentration unit is mole per liter. Then unit for time is second. So unit of rate of the reaction is equal to mole per liter per time or mole per liter per second. So this is about the rate of the reaction. Next, we are going to see about the example. Let us consider the example. So the example A plus B. Here A and B are reactants. Both the A and B react together to give the product P. So we can say how to write the rate. The rate equation is we can say in the two ways. First way is rate can be expressed in the way of decreasing concentration of the reactant, and the same way we can predict by the increasing concentration of the product. So in the if you are considering the reactant, as time going on the concentration will decrease. So the rate of the reaction carries in favors of negative sign. In the case of product, as time going on product will form gradually, thereby we could consider the product concentration will increase gradually. So we can give the definition for rate of the reaction. So rate of the reaction is nothing but the rate of the reaction is the speed of the chemical reaction or the change in concentration per unit time. Then how to write in the form of rate equation? So change in concentration is equal to dC then divided by time. So that is small change in time. So that is dt. So small change in concentration per small change in time. So in the case of reactant, we can consider rate of the reaction which favors negative sign. So in such case, we can give negative sign. So rate is equal to minus dC by dt in the case of reactant. If you are considering product concentration favors for positive sign. So in such a case, the concentration carries positive. So rate is equal to plus dC by dt. Next, we could see about the important factors which affecting the rate of the reaction. What are the important factors? which affecting the rate of the reaction. Any reaction, some influences will be there. Here 5 important factors affecting the rate of the reaction. First one is concentration. So, what is concentration? We know concentration is, let us consider a solution. Each and every solution will have 2 components, solute and solvent. So, what is solute? Solute is the minor quantity of the substance which is dissolved in the solution or dissolved in the solvent. So, solvent is the major component. So, we can say the solute is mainly predicted for the concentration of any solution. So, if the concentration of the solute is high, we will say it is the concentrated solution. If the concentration of the solute is less, we will say dilute solution. So, as the number of molecule increases, we can say concentration also increases. So, at higher concentration, we can say the molecules will come very close to each other. So, all you know about the concentration. Then we must know activation energy. So, what is activation energy? We know very well the minimum amount of energy which is required for the chemical reaction. To have a chemical reaction, minimum amount of energy must be there. That energy is known as activation energy. So, how we are gaining the activation energy? How the molecules are gaining the activation energy? So, according to collision theory, the molecules must collide with each other before they undergo chemical reaction. Then only the molecules will give the product, or the reactant will be converted into the product. So, to have a chemical reaction, the minimum amount of energy is said to be activation energy. Each and every molecule possesses activation energy, then only they will undergo chemical reaction. So, that energy is said to be activation energy. So, in the case of higher concentrated molecule, what will happen? The molecules will come very close to each other, they will make proper collision with each other, thereby the molecules gain more and more energy. So, more and more energy means they will give more product. So, rate of the reaction will increase gradually. Let us consider the graph. The graph is plotted between concentration versus time. Here 2 lines are there, red line and blue line. The blue line shows the product curve and the red line which indicates the reactant curve. So, from there we could say the concentration of the reactant gradually decreases and the product concentration will time to time gradually increases. That is what shown in the graph. Next, effect of temperature. As temperature increases, rate of the reaction will gradually increases. Even more of temperature increases, the molecule gains more energy, the molecule will begin to vibrate. Due to molecular vibration, the molecules will collide with each other vigorously, thereby the rate of the reaction will definitely go to increase. But one more thing here, the important concept we could know is temperature coefficient. Temperature coefficient term is nothing but for every 10 degree rise of temperature, the rate of the reaction increases twice. So, that is temperature coefficient. As temperature decreases, the molecules will keep away to each other. So, the molecule will make less collision, thereby rate of the reaction will decrease. So, that is what properly shown in the figure. In the figure, the graph is drawn between fraction of molecules versus kinetic energy. So, 2 curves are there. First one is high energy barrier and another one is low energy barrier. In the case of high energy barrier, that falls at a low temperature. So, it will take more time to have a high energy barrier. So, thereby the energy barrier height will be high, but in the case of low high temperature, the energy barrier will be low, the molecule easily converted into product. So, this is what we have seen about effect of temperature. Next one is effect of catalyst. Effect of catalyst. What is catalyst or what is catalyst effect? Catalyst is a substance which will either increase or decrease the rate of the reaction. We have seen in many cases, for example, the decomposition of potassium chloride, the less amount of manganese dioxide is enough to increase the rate of the reaction. So, in most of the cases, rate of the reaction will be increased by the action of catalyst. In few cases only, which will be decreased by the influence of the catalyst. So, by adding the catalyst, what will happen? the reaction will be proceeded in different pathways. So, as I said earlier, in the case of temperature, two energy barriers will be there. First one is low energy barrier and high energy barrier. So, in the case of low energy barrier height will be less. So, when we are adding catalyst, the number of molecule will be easily cross over the low energy barrier, thereby which will give more product. So, thereby we could say rate of the reaction will be increased. Next one is surface area. What is the surface? We know surface is area is the topper part of the molecule. So, as the number of surface area increases, what will happen? Surface area will have more active sites. Well powdered compounds or molecules will have more number of active sites. So, in the case of number of active sites increases, what will happen? The molecules will come to accommodate on the active sites of the surface area. So, the molecule will get a possibility to react with each other. So, the product formation will be highly favorable as the number of active sites will be increased. So, thereby you can say more surface area favors for the more formation of the product. So, we could say rate of the reaction will be increased. Next one is what? Nature of the reactant. Nature of the reactant in the sense we could consider bond. So, bond between the two atoms. So, two atoms are attracted by a force of attraction. So, that we are saying as a bond. So, there are several types of bonds are there, ionic bond, covalent bond, coordination bond, etc. So, in the case of ionic bond, we know, so when the reactant is converted into product, the reactant bonds will be broken away and new bonds will be formed for the product. So, bond broken and bond formation will be taken place simultaneously. So, thereby we could say if the bond is made up of ionic bond, it is very easy to break and form. So, we can say ionic bonds are very rapidly forming the product. Ionic bonds are easily undergo chemical reaction. So, rate of the reaction will be increased. But in the case of covalent bond, it will take bit of time to convert it into product. So, in such cases, rate of the reaction will be decreases. So, another one is rate law. What is rate law? Rate law is nothing but the rate of the reaction is directly proportional to concentration of the reactant. So, only depending upon the concentration of the reactant. Let us consider a reaction A plus B gives product. Here the concentration is depending upon the reactant. So, hence we can write the rate is directly proportional to concentration of A into concentration of B. So, we can say rate is directly proportional to concentration of the reactant and product. This is what called rate law. Next one is order of the reaction. So, order of the reaction is nothing but the number of concentrations times on the powers of the reactant. So, to say in a definition, order of the reaction is sum of the powers of the concentration terms of the reactants. That is what order of the reaction. So, next class we will say what are the types of order of the reaction, etc. Thank you.